Hey there, my name is Priyansh Nayak, and today I'll be demonstrating my multi-bone inverse kinematics arm solver using a custom FABRIK implementation in Unreal Engine using only C++, no blueprints whatsoever. So this opposable character class is what defines one of these guys over here. These guys come with their own custom skeletal mesh that you can look at and edit, as well as all the fabric logic and a spline component that you can see over here, which you can control to animate your own custom path. To briefly describe how I implemented this fabric solver, I allow you to edit the bones. So in generally it's going to be the right hand arm composing of a three bone structure. This allows you to also edit it to a left bone, as you can see with this guy over here, or mess around and try a leg approach, although the constraints won't be accurate. I developed my solver such that it stores the positions of these bones and it calculates the distance from the edge of the shoulder point all the way to the hand bone and compares it to the little red target space you see on the ground. It will try to perform general fabric implementation by putting the positions and then tries to orient it properly and apply different constraints such as the shoulder joint constraint, the elbow constraint, and wrist constraints that I have over here. I go more in depth about this in the report, but in a gist, the positional computation involves a backward and a forward pass between enforcing the constraints in the scenario that the ball is reachable. In the case that is not reachable, it just tries to stretch out the arm as much as possible in the direction of the ball. And then it applies the constraints depending on the bone structure. And finally, it orients the rotations correctly so that they are not bending in a weird way. Finally, I also have a little additional experimental head positioning behavior where it just follows the ball along. It is not entirely accurate. There are a few nitty-gritties that I am unable to resolve, but it generally follows the ball around as it moves on the spline. Without further ado, let's quickly simulate. And as you can see, all of these guys have a little custom idle animation that I might created over here, which basically just has them move around a bit, have a little bit of a breathing animation, turning their head around, stretching their arms, loosening their legs, all of that. Obviously, the waving animation that was provided in the starter code is still preserved. It's not used. Um, they start in the idle state, and you can activate this IK arm play stop button in order to show the spline based animation that uses my inverse kinematic solver. We can display it for each of these guys following their own custom spline path, and you can see how the constraints are enforced properly so that we're not experiencing very weird rotations. And each of these guys try to follow the path properly and try to stretch as much as they can. And when the ball is nearby, it tries to apply to the palm. So one note about that particular aspect of the palm is that the standard bone structure doesn't really extend to an actual palm. So the hand bone solves around the wrist. In order to counteract that, I basically compute the palm myself using the 4 metacarpal and just have an extended state so that ball actually sits on the palm instead of like awkwardly sitting on the wrist. I try to further induce a finger curl system, but it wasn't very successful, so I had to scrap it. And as you can see, sometimes the heads don't really look in the right directions, but they're mostly accurate and they follow the spline along properly. And yeah, in a gist, that is my entire system. This runs in a 25 iteration approach. There can be some nitty-gritties occasionally due to the competition happening in real time and not just being preserved. But other than that, that is my whole approach. You'll find all code about this on the GitHub link in this video description as well, and a more detailed analysis of this entire project in the report. Thank you for watching, and I hope you learned something new.